Hello, hello, and welcome to The Signal State. This is a puzzle game. It's a Zachlike, if you know what that means. I'm going to be connecting wires to make circuits happen and such to get graphs to show up. I'm not sure exactly. Let's just hop in and see. Our machine stopped working years ago. Not just ours, everyone's. Our computers, our appliances, everything. No one knows why. Entire cities ground to a halt. I wasn't even born when it happened. All I can remember were the distant dark cities hidden in smog. So here we are. Building everything from scratch, putting the pieces in the right places. My radio crackles to life. You should be nearly there. Do you see it? Hold on. Yeah, I think I do. Wow, it's in quite a state. That's where you come in. That farm's your home now, and it needs some fixing. Guess I should settle down and get started. Yes. You're going to be alone for now, but hopefully not for long. Go forth. Rebuild. Hey, it's me, Miriam. All settled in? We have some tabs. Sure. I'm ready to begin. Good. First things first, we'll need to recalibrate your modular rewiring system. Might have got knocked about on your journey to the farm. Ready to begin? What does this thing do again? All the machines on the farm are going to need their internal electronics rewired. That's your job now. We sent you out with your own personal modular rewiring system. With it, you can design circuits that will emulate the behavior of the broken components within the machines. We're going to hack and repair these machines so we can get this farm up and running again. With it, we can produce more food and support more people. It's easier if I just show it to you. We have to recalibrate your system anyway, so the sooner we begin, the sooner you'll understand how it works. Well, let's start. Diagnostics text. To verify the signal pipeline works, connect source 1 directly to both out 1 and out 2. Rewire circuit, repair machine. Start with source signals, transform them, send them to out sockets. There's the brief, that's what we have to do. Use the modules to transform signals, connect them with cables. Click and drag on sockets to create cables. Black sockets are inputs, black sockets are outputs, white sockets are inputs. Inputs can only be connected to outputs. Connect source 1 to the split input. Split takes in one input signal and duplicates it to multiple output signals. And then connect the split outputs to the out sockets. Right, so here's our split. That's our source, so our split is going in there. It looks like it comes out in 4 different channels. We only need 2 of them. And it works. It does in fact work. And loads of people have the same score, unsurprisingly enough. Excellent, your system works perfectly. You're ready to begin. Start cataloguing the machinery on site, start with the simpler ones. Okie dokie. Power generator. So what's the end game here? Why are we repairing this farm? We already have our current one and it's giving us enough food. Well, we will have surplus food and more space for our community for one, but I think we can do more than that. More? It's too early, I think, to talk about that at this juncture. Not everyone here agrees with me on the plan. Not yet, at least. Okay. Let's get the power generator going. It's an Elis Agritech generator. What is that? Corporation from the old world, possibly the biggest manufacturer of agricultural equipment. Rare is the farm without any Elis Agritech machinery. Send source to output 1 with a signal intensity tripled. Okay, what else do we have here? We have a speed adjuster. We can step forward 1 input set at a time instead of going through the whole thing. Lock cables, lock modules, delete. I could record a GIF. Sure. Split takes in 1 input and duplicates it to 4 outputs. Some takes in up to 4 outputs and some of them up to 1 input. Alright, so we want to triple. So we go 1, 2, and 3. Feed out to out. And that should do it, I think. Still very easy tutorial-y puzzles. On we go. I suspect you'll have a lot more Elis equipment to deal with on your farm. Is that a problem? No, not really. It's just Elis Agritech is a name with historical baggage, shall we say. It's not my story to tell. Circuit breaker. A little bit of math, a little bit of logic. So all these systems are a little bit of math, a little bit of logic. It's not magic. I'm impressed human beings ever managed to make stuff this sophisticated. I'm not. Out receives signal 1 signal increased by 5 volts. Out 2 receives signal 1 signal with intensity halved. The module catalogue shows what modules are available for this circuit. Read their descriptions to understand their behaviours. Drag any module to add it to the rack, such as this. Ooh, if I can mouse over it properly. Attunator. Takes an input and reduces its intensity, inverts it, or both. Sure. We've got one of those. You can drag on existing modules to rearrange them, drag them away from the rack to delete them. We also have the down here. Delete that. Some modules have adjustable controls that affect their behaviour. Adjust the bias amount until it reads 10 by adjusting the knob. Plus 10. Knobs can also be adjusted with the scroll wheel or by typing into the numeric display. 5. Toggle between the module catalog and the input-output panel. Expected input-output, yes. Signals are always limited to a range of minus 100 volts to 100 volts. Okay. Reduces its intensity, inverts it, or both. Okay. Well, we want to do 2 different things, so let's hook up the split first. Bias takes an input and shifts it by a constant offset value. If no input, bias outputs the offset value. Ah, I see. So yeah, we want to hook in that, and we want to feed that to out 1. Now, our attunator here. I assume this is 50% of the current value and not additive 50%? We'll find out. It in fact is. Great. Excellent, in fact. The generator is now able to effectively route power to whatever systems are in need of it. Time for the next step, which is... bring the machines to life. Continue cataloguing what you have on site and what needs fixing. Some of them are simpler than others. Start by getting some of the lights in the farmhouse up and running. Lights sound easy enough. Lighting circuitry is not too complicated. Some voltage levels will have to be altered to prevent blowing the lights out. You're right to feel cautious. There won't be strangers out in the wilds and they might not have the best of intentions. Yikes. Bandits are a thing this far out in the wilds, so get to work. Out 1 is source 1 and source 2 summed together. Out 2 is source 2 subtracted from source 1. Change the speed, color code cables, right click on an existing cable to update its color, get hints, there's a notepad, oscilloscope displays the last 8 values of a given input signal, and a notepad where I can write text. Great, well... we're gonna want to do some summing, I think. Let's get 2 splitters. Let's have blue for source 1. And yellow for source 2. Right, so the first thing I want to do is I want to take a copy of source 1 and I sum it with a copy of source 2. And I feed it to output 1. Step 2. Subtract source 2 from source 1. So, I'm gonna need one of these, I think. We set this to negative 100. We take our source 2, which is yellow. Feed that in there. That'll turn the source to negative. Which means we can now add that negative number to source 1. Here's negative. Here's our source 1. And then hook that up to output 2. I think I've done that right. Let's see. Those indeed look good. Excellent, with the lights on you should be able to get work done even at night. Am I expected to work nights? No, of course not, I leave that choice up to you. The sooner you get your equipment up and running though, the sooner we can send people to help you run the place. So those machines are going to need new modules added to your rewiring system. I'll let Gordon deliver them to you when the time comes. Gordon? You met him briefly before heading out. I'll let him introduce himself later. VCA test. Hello, it's me, Gordon Lee. We met briefly before you departed headquarters. I issued you your modular rewiring system. I sent a delivery drone over to you with some new modules last night. Did you get it? I apologize, just thought you might want the new modules fresh out the workshop. Does the freshness make a difference? Absolutely not. Fantastic. Voltage-controlled amplifiers, also known as VCAs. Are you familiar with them? I'm not. VCAs control the intensity or amplitude of a signal with another signal. This other signal, known as the control voltage, or CV, is treated as a percentage value from 0% to 100%, and is then multiplied with the input signal. At 0% the input signal is completely muted, at 100% it's sent through unchanged. At any percentage in between, the input signal has a reduced value. Basically, think of a VCA like a faucet that controls water flow, except you control the water flow with another water flow. I'm sure it will make sense. Off we go. At each time step, out 1 receives a specified percentage of source 1's signal. Percentage value is specified by source 2. So, we're gonna want one of them fancy new VCAs. We specify our percentage value with source 2. We feed in our source 1. And we output the result. Like that. So, for example, minus 50, 40% of minus 50 is minus 20. Step. 100% of minus 35 is minus 35, of course it is. 80% of 25 is 20, yup. And so on, and so on, and so forth. I understand. Great job, you're a natural at this. Okay, let's not get ahead of ourselves here, we've only just started. Hey, just heard from Gordon. Good work, you're well on your way to getting that farm back to its usual glory. Barn lights. More lights to jumpstart. The barn lights are a bit more complicated. They have variable intensity controls, for when the horses get grumpy, I guess. I'll give it a shot. Send source 1 to out 1, but with its intensity boosted by 50%. Send source 1 to out 2, with its intensity boosted by a percentage specified by source 2. We can add a breakpoint. Great. I don't think I need that. Not right now, anyway. Okay, we are gonna want a splitter to begin. Out, in. I think this is the same as it was last time, right? For output 2. No. That's because I have hooked it up wrong. Like that. Still no. Source 1 to output 2, intensity boosted by a percentage specified by source 2. Boosted by. Okay. Fine. There's an extra step here. We want to then sum this with that. Looks good. Now for output 1. Density boosted by 50%. This is going to be similar-ish. Right, we have our 50. Want another one of these. What colour wire do I want to use for this? It doesn't matter. This is going to be a hodgepodge of wires. That goes in. 50 goes in. And we want another sum. Feed that in, feed this in, feed this over here. Bada bing, bada boom, bada boom. Full speed ahead. And I got an achievement for completing the tutorial. Fantastic. That was all tutorial. Great job! If we found any horses, I know where to bring them now. What's a horse? Wait, you're kidding, right? I know you were born after the collapse, but horses aren't extinct. What? What's a horse? I'm going to have a lie down. I feel old. I await your explanation of what a horse is. Firmware programmer. Before we proceed any further, we need to repair the workshop's firmware programmer, a vital bit of kit for burning firmware on some of your more advanced modules. It's digital and still operates with binary signals. The VCA is still useful though. You can use it like a gate. Like a gate? Remember how VCAs alter the intensity of the input signal based on another signal called the CV? Well, if the CV signal is only ever either at 0 or 100 volts, the amplitude of the input signal isn't really changed. Instead, the input signal is either passed through without change or is completely muted. Well, the VCA can function as an automatically controlled mute button. You might have an input signal that has some unwanted signal values in there for certain periods. You can use the VCA to filter out those unwanted values and leave the other values untouched. Let's see it in action. Source 2 is a binary signal. When at 100 volts, send source 1 to out 1, otherwise send nothing to out 1. VCAs can be used as gates. If the CV input only ever receives 100 or 0, the output will always be either 0 or the original input signal. Here's our VCA. I think this is all we need, really. Feed in our source 2, our source 1, and our output, and I think this might just be straight it, right? Precisely. There you go. Simple enough. The real challenge with using VCAs as gates in this way is generating the CV signals. You need to generate a signal value that is at 100 volts when you want it, and at 0 volts any other time, and nothing in between. Sounds simple enough. Not always, it can get a bit tricky. We'll see soon enough. Power regulator. The power regulator on the firmware programmer is a bit more complicated. It's a dual transistor circuit, so you need to check the binary values of 2 different signals. It's not too difficult, just give it a shot and we'll be here if you need any help. Source 2 and source 3 are binary. When they are both at 100 volts, send source 1 to out 1, otherwise send 0. We want to create an AND gate, basically. When this and this do that. So. Whoops. Yeah. Just like that. And we want another one. Hook in our source 1, hook in our output. Simple! Nice work. I think you understand VCAs pretty well now. Thanks. Logic test. Now the firmware program is working, we can get the logic modules working and give them a test. Logic? You know. Or and not. I do know. Right. Make an AND gate. Make an OR gate. Just begin. I'll read it in here. If source 1 and source 2 are both 100, send 100. Okay, 3 different outputs. Right, fine. Or. And. Not. In 1, in 2, out. There's our AND. We want an OR. Well, gotta split everything first, I guess. Let's get a yellow. Put blue in there and in there. Yellow in here and in here. You can be red. 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 If source 1 and source 2 are both 0. I don't need to not both. I can just do a... That's an OR, which is wrong. And give me another splitter. Take the blue out in. Yellow out in. Red. Output over here. We want to send it straight out, but we also want to convert it for the other output. Not quite. Fine. Scrap that logic. I do need to invert both. There. There it goes. I know how logic gates work. Drinking the water. Logic modules are really powerful. You're not just doing basic math now, you can change how signals flow with logic. I do know what he means. I can do logic. Min-max test. Min and max modules. Min takes in two outputs and outputs the smaller, max does the opposite. Let's go! Source 1, 2, and 3 are random signals. Out 1 receives the greatest signal of the three, out 2 receives the smallest. Should be easy enough, we just need to chain a couple. In 1, in 2, get that, do that, hook it up, and, wow. Guess I do got to split everything. Put 1, output, output. There, that there, and that there. Give it a run. And it fails utterly. Alright, back to the beginning. Let's give it a debug and have a look at what it's doing. This isn't a great example because 2 of them are 30. Alright. I want a test case where they're all different and all positive. That's easiest to look at. Well, I've got them reversed. For a start. There it goes. Just had my output swapped. No big deal. Alright, you got it. Anyway, enough hand-holding. Then let's try more complex circuits. Let's. That's the spirit. Irrigation system. I trust Gordon has done his job well. You should be decently familiar with how VCAs and logic modules work now. I think so. We'll move on to the next step. We need to prepare the crop fields for planting, which will require a functioning irrigation system. First component is the central pump. It provides a very precise rate of flow of water, so you'll need to regulate the flow using the given control signals. Combine the concepts you've learned so far, VCA gating and logic. When source 2 and source 3 are at 100 volts, send source 1 to output. If either source 2 or source 3, but not both, are at 100 volts, send the inverse of source 1 to output. If they're both at 0, send nothing. This does indeed look a little bit more complicated. Okay. First up, we're going to need a couple of splitters. Let's do an AND. There's our AND. We also want an OR. There's our OR. do I want to organise this? And well, that's wrong. Let's just do that. That's fine. Make things a little bit less cluttered. I also want to split this. This is my main control. Output. And so there's condition 1. One thing at a time. If either, but not both. Send the inverse. So, attuator to inverse. If they all then invert I don't have max or min here, which would be helpful. I think some should work just fine though, because if either of those outputs don't exist, they're just going to be 0, which is fine. Well, it's close-ish. It's because I need to do an XOR setup somehow, an exclusive OR but not both. Or and look, that there, or and not and great. Let me try and explain why this works, if I can. We want to do XOR, so we want an OR, and if it's not an AND. So we get our AND, we split it, because we already have an existing AND. We hook up the AND to a NOT, so this is NOT AND. And then we compare that to our OR, and say OR, and it's NOT AND. That's an exclusive OR, an XOR. And we just hook that where it was going before. Hopefully that makes sense to you. Excellent work. Thanks. Can you hear the water flowing through the pump? That's the sound of life right there. Exciting times. Indeed. Irrigation distribution circuit. While the pump is working, you need to rebuild the distribution circuit. The circuit takes the water flow and distributes it to the different irrigation channels. Off we go. Source 1 is an input signal. Source 2 and 3 are CV signals for two different VCAs that control the intensity of Source 1. If Source 1's intensity is higher when controlled by Source 2, send Source 1 controlled by Source 2. Otherwise, send Source 1 controlled by Source 3. This seems easier than the previous one. We want to split. Send it to our two VCAs. Plug in our CV signals. Now we want to see which one is higher. And send the higher one. Not entirely sure what business this puzzle has being later than the previous one, but sure. Irrigation system is nearly up and running. Irrigation controller. The last step of the central irrigation controller. It receives the signals from the main pump and the sensors and controls the water flow. You'll see. Okay. When the signal from source 1 is more than 25, out 1 receives 100 volts, otherwise it receives nothing. Out 2 checks the value of source 1 signal after it's been decreased by 25. If the signal is still more than 0, out 2 receives 100 volts, otherwise it receives source 1 decreased by 25. Okay. First thing we need is a constant offset value. 25. We're going to want a splitter for at some point. Do not move the system source around. I wonder if there's a wacky way I could do this. What if we set you to 75? Summit. And then feed it through a twin set of knots. Does this work? No. check if it's positive with a NOT gate. And invert the outcome. Correct. Now for out 2. Where, conveniently enough, I can use this same result here. Swap the cable color. In fact, we can do it here, can't we? Can we just reuse basically all of this logic? I may need to press the hint button. I've got to set up an if-else somehow, and I'm not too sure how to do that. Let's try it and see. I could get help on Discord. No thank you. I know that. I've done that bit. I've kind of done that bit too. An OR with a single input will output 100 volts if the input is more than 0 volts. It's literally just gonna be this then, isn't it? We plug in our output. Close. So let's grab a sum. Not helpful. Gonna need to not that output then. Still not helpful. No, it's always gonna be 100. I need the... that. I need the that. The that is what I need. Cool. Got there eventually. I didn't even realize the OR would work with only one input. Now we know. So we have the existing logic, which was easy enough with the bias. And we're adding on a check Is it bigger than 0? If it is, we're sending in 100. If it isn't, we're sending in the minus 13. We're sending in the number, whatever it is, actually. It's just, if it's a positive number, it doesn't matter, because it's going to be added to 100, and the maximum is 100, so it's always going to end up being 100. Makes sense. Good! Things are starting to come together. What next? The radio broadcast system. Sounds important. The next step, I'm going to need to calibrate the farm's radio broadcast system. You're going to need it for communications. I can already talk to you. Okay. We'll just get on with it then. I program things because the plot demands. Source 1 is a random signal with occasional voltage spikes. Voltage spikes are always at least 75 volts. Send source 1 to out 1 with the voltage spikes filtered out. At these timestamps, send a 0 instead. Sounds kind of similar to the previous puzzle. So we want a bias, we want U set to negative 75. We want a split, because we want to retain this original input. Throw that in there. Now we want to check if this is greater than 0. If it is greater than 0, we want to output that. If it's not greater than 0, then instead we want to output our input. I think it might just be this. It isn't. But it makes a fun sound, so that's nice. 91. 91 minus 75 is 16. Which is in fact greater than 0. I need to knot this. Not. Try that. Well, it's filtered out the spikes, it's just boosted everything else as well. 9... Right. Sum is not quite going to work. And this is going to do the 91. I've kind of done the opposite thing from what it wanted me to do. Kind of. But not quite that either. It's fun, it just works by default when there are spikes, because it's not sending in anything. I wonder if I can use that. We just want... Yeah, we just want to hook in this, don't we? Put that there, that there. And there we go. Again, seems easier than the previous puzzle, but I guess I do have the advantage that I know how the OR works now. Miriam, with all due respect, that is a terrible idea. We're just going to attract trouble. Do what? You think everyone out there wants to hurt us? That's oddly cynical of you, Gordon. I'm being realistic. We managed to survive so far because of our discretion. This is dangerous. That's the point. We've done survive. We need to do more than that. We need to thrive. I can't believe this. I'll come around. Do what now? Do what now? What am I broadcasting to the world? More radio-related things, including some optional stuff for the first time. Might as well. Improve the amplification circuit to make the signal clearer. Distribute signals from source 1 to out 1 and out 2. If source 1 is less than or equal to 40, then out 1 receives source 1 and out 2 receives 0. If source 1 is more than 40, out 1 receives 40 and out 2 receives source 1 minus 40. Okay. Immediately plugging in the split. Immediately plugging in the bias. Minus 40. Greater than 0 check. In fact, no, I want to split this as well, because I'm going to need this later too. Then do the greater than 0 check. Equals 33. Is it greater than 0? It is. In that case. And we don't have the min and max. Not that they would necessarily be of any help. But still. Achieves a whole lot of not much yet. 73. We don't need the knot. That's looking better. And if this is not the case, then split that there, hook that into the knot, hook that there. Grab our output to down here. Hook in our original signal up to the sum. Out 1 complete. Now for out 2. If signal is less than or equal to 40, receive nothing. Well, it does that already. If it's more than 40, receive our number from here. So I'm gonna want a pretty similar setup again. Let's maybe just move all of you up there. I don't need to recolor my wires, I know it works already. I will grab a new color for this though. Maybe slide this up there as well. We don't need it down here, I don't think. We want this here. Kind of. Though not directly like I've done it there. In, out. It just works. I didn't even expect it to just work, but it just works. Well, that's just excellent. Hello? Never mind. The radio has been amplified. Hey, one of our engineers came up with this design for making spare min and max modules in case you don't have enough. You'll have to complete the design though if you have time. It's not my place to explain. Let her. Okay. So we're making our own min and maxes now, are we? Build min and max comparators. At each time step, compare source 1 and source 2. Send the higher to out 1 and the lower to out 2. Cool. We don't have them, so I'll make them myself. Okay. We are going to want 2 splitters. We are probably going to want them color-coded, so I don't lose track of what is what. Bias. I don't think that's useful. This will be. we're flipping our input 1. We now want to add that to our input 2. That's going to come up with a number. I need to do the same thing but the other way around. Feed in our output 2. Sum it with the regular old output 1. And I need to work out which of these numbers is the negative. I probably don't even need 2 of these setups, do I? At least the 1 would do. Probably. I'll leave it alone for now, though. We can change it, if need be. But not. Grab a split. One of these goes in, one of these goes out. Grab this, I want to grab that. This may be totally the wrong way round, I'm not sure yet. I haven't really been paying attention. Seems like that might have been the case. It was. Now I kinda need to invert this whole system. Goes on this side. This goes on that side. up a red. It doesn't matter what colour everything is. And that time I got that the right way round first try. Great. Now, for the arguably trickier part, which is trying to explain why this works. We've got two numbers, we need to work out which is bigger. We're gonna need to take one away from the other. So we flip one of them, and then we add them together, because we don't have a subtract. So we've got to invert and then add. We arrive at a number, which is our difference between source 1 and source 2. If the number is negative, then it means source 2 is higher. If the number is positive, it means source 1 is higher. Fantastic. We take that number, we OR it, to get our is it source 1 or source 2 higher. This is our most important bit of information. Split that a bunch. Also not that a bunch, because we want the opposite version. We then take these yes or no's, which is higher, we plug them into a bunch of VCAs. If source 1 is higher, then we let source 1 through all of the time. Well, we let source 1 through on the top, and source 2 through on the bottom, because we want the lower to end up on the bottom. If the bottom one is higher, we do the same thing in reverse. Give me a case where the bottom one is higher, please. Like that. Flip it. Add the two results from each comparison together. One of them is always going to be 0, one of them is always going to be our output. Chuck them into the out. Huzzah! Nice work! Sometimes implementing the behavior of a module from scratch really helps you understand the nuances of the module.